Hello everybody. I first want to thank ICNLSP for giving me the chance to present and to share our work with you today. My name is Lucía, and I am currently a PhD candidate at University of Geneva. And today I will be presenting some of the work that I have conducted on a BERT-based fine-tuning approach to enhance sentence complexity assessment for text simplification. I will start by introducing the fields of text simplification and sentence complexity assessment. In section 2, I will discuss how we collected data for our experiments. That will be explained in section 3 along with the results. And I will finally wrap up everything in the conclusion. So the first question that we need to answer is, what is automatic text simplification? And well, it is precisely what the name suggests, which is creating an equivalent version of a text where we aim at reducing its linguistic complexity while still retaining the original meaning and information. In some way, we can imagine this process of simplification as a question of form and substance, where the idea is that we want to change the form, the appearance of the text to reduce its complexity, but we still want to maintain intact as much as possible the underlying meaning that is like the substance. Even if ATS can be a promising task for text accessibility, its implementation is problematic because of the scarcity of large-scale parallel data, which is even more acute in less resource-rich languages than English. And this points to the interest of resorting to sentence complexity assessment, SCA, as I will call it from now on, to help distinguish complex and simple sentences from comparable corpora, and in this way train ATS models. The thing is that current approaches for discriminating these two categories seem too coarse for ATS, especially because these models often assign a discrete label to an input text in an absolute manner. But this seems not well suited for simplification, especially because it's inherently a relative process. We rewrite a given text into a simpler version. We cannot simplify in a reference-less manner. And this suggests that a binary classifier that agnostically assigns a discrete label to a sentence, it's too limited. And we believe that ACA should be also conducted in a reference-aware manner. And this is why we aim to provide a better suited method so that it can be helpful for to select relevant complex simple pairs for the ATS task, and in this way serve as a preliminary step to create label data. Also, given the scarcity of resources affecting this task, we have decided to implement our method on French, which, despite being a well-resourced language, doesn't have specific resources for simplification. So with this work, we propose a triad of increasingly fine-grained models that can help us detect good candidates of complex to simple pairs from comparable corpora, where we first determine whether a sentence is complex or simple in the absolute terms. We later assess if the second sentence in a pair is simpler than the original one. And if so, we finally measure the simplification gain achieved by the second sentence. So in order to do this estimation, we needed data. And we opted to rely on Wikilarge, which is a well-established parallel data set for ATS, with the caveat that it is originally written in English. So we translated it into French with the use of Google Translate. And in this way, we created an equivalent version, Wikilarge French, where we also filter out the pairs that were too similar. And then we split the data into a train depth and test set. Then, since we also conceived this approach as a reproducible method to automatically create parallel simplification data sets, we also compiled data coming from comparable corpora in French language, coming from wiki-based resources And so same domain and definitional style of Wikilarge. And we actually mined the French editions of Wikipedia and Wikidia, where Wikidia is a simplified version of Wikipedia that aims at making articles easier for children. And we got the content coming from both encyclopedias using the web scraping pipeline described in a previous article, which returned about 1,6,500 Wikipedia sentences and 1,035,000 sentences in Wikidia. And before proceeding to the implementation of the SCA models that I will be introducing afterwards, we performed a meaning preservation pre-filtering step. Actually, as we previously stated in the introduction, a simplified text is expected to meet two primary conditions. First, retain the meaning conveyed in the input text, and second, obtain a simplicity gain with respect to the reference. So based on this definition, we first need to assess whether two sentences are semantically equivalent or not. And for this, we used SBERT transformers to encode the sentences into a vectorial space and then compute their cosine similarity to determine which pairs were semantically consistent. And then on the basis of a manual annotation, we were able to draw a cutoff threshold of the pairs exhibiting a sufficiently high semantic overlap. But of course, similar pairs are not necessarily valid simplification pairs. And this is where a triad of increasingly fine-grained models come into the picture. And so to elicit relevant complex to simple pairs, we propose our own SCA approach consisting of on three different steps with different levels of granularity. And to do that, we used the French Wikilarge dataset to fine-tune FlowBERT, a French LLM, for two different sequence classification tasks and for a custom regression task. So for the first stage, we used Wikilarge to classify each sentence as complex or simple, and we assigned a binary label for each of the complex simple sentences in the dataset. And in this case, we treated each sentence in the pair independently. And when comparing the performance between an untuned model that we used as baseline and the one after training, the tuned one, we saw a significant improvement. But as we previously said, an absolute classifier is not enough for ATS. And this is why we also aimed to answer to the question of whether the target sentence is a simplification version, is a simpler version than the source one. And to do that, we juxtaposed the Wikilarge sentences, alternating their order so as to signify either a simplification or a complexification process. And from the results that we obtained, we saw that there was a significant improvement, again, between the baseline and the tuned models. And actually, the performance of the baseline classifier mirrors the class distribution and can largely be attributed to chance. But the tuned models improved the results significantly to 94 accuracy. And to reinforce its validity, we also used a manually annotated data sets on relative simplification that we extracted from the compiled Wikipedia data. And the results show, again, a good performance and a good generalizability of our tuned models. And finally, even if the previous models can help discern if a sentence is complex or simple, or has undergone a process of simplification or complexification, it does not allow us to quantify the simplification shift produced within a pair of sentences. And this is why we also measured the simplicity gain achieved from the original sentence to its simplified version with the training of a regression model, where the gain score is defined on the basis of a set of pertinent features that we grouped into structural, lexical, and syntactic. and which are widely used in the previous literature of for SCA. And based on them, we calculated their values for each sentence in the wiki large pair, then performed an element-wise subtraction, and we finally got a final normalized gain score. And then again, we fine-tuned FlowBERT for our custom regression task, where the input received was the complex to simple pairs appended to their simplicity gain score. And the table shows that tuned models achieve a much lower mean square error than the baseline. And the most performing one, FlowBERT large, yields the best performance with 0.23, which is good, but suggests that we still need to optimize the model hyperparameters in the context of our application. So using the most performing models, we implemented our fine-grained sentence complexity assessment on the data that we mined from Wikipedia, and that we mentioned in section 2. And in this way, we automatically collected a good number of examples that could be later be part of a label simplification data set. So here's one example where the absolute classifier categorizes the first sentence as complex, the second as simple, and where the relative classifier agrees by predicting that the second sentence has undergone a simplification process with a simplicity gain of 0.84. And so here we have a standard valid complex to simple pair. But we can also encounter a situation where the absolute classifier tells us that both are complex, and that's when the relative classifier comes in handy and tells us that we have a simplification example. And we can see indeed that the target sentence is comparatively simpler than the source, which also constitutes a valid complex to simple example. And finally, we can have a converse situation where we have simple and complex given as labels for the absolute classifier, and then a complexification process predicted by the relative classification model. So here's an example that wouldn't serve to our parallel data acquisition purpose, although we could even reverse the order of such examples to provide with complex to simple pairs. And so with the application of this fine-grained CSA approach, we were able to compile a corpus of around 45,000 sentence pairs that we called Widico, and that is available on the GitHub repository for public use. It contains standard examples of complex to simple pairs, but also the relative ones that we just mentioned. And with this work, we have presented a new approach for SCA, which we have aimed to make increasingly granulated so that it can be suitable for creating parallel data sets for text simplification, which is necessarily a relative operation, as we mentioned before. Also based on our method, we provide a general purpose parallel data set in French that can be further used to fine-tune LLMs for the task at hand or to assess text complexity in a more granulated manner. And as for the limitations, it should be noted that due to the volume of the wiki large corpus, we resorted to Google Translate to obtain the French texts, and we didn't manually assess the correctness of the outputs. So in the future, we will need to conduct a human evaluation to check the translation quality. And when it comes to the further work, we plan to extend our investigations on two directions. First, we plan to embed our models into a larger pipeline designed for ATS and use them to rank a set of candidate sentences with the goal of selecting the most simplified one that best preserves the original meaning of the input. And we also would like to improve the interpretability of the simplicity gain score, because even if it's based on established linguistic features for text simplicity, we believe that it's also necessary to contrast such scores to human judgments and investigate the correlation between the two. And that's all. Thank you very much for your attention.